Okay, so remember, like way back when, every single gadget had its own charger. Like your phone charger wouldn't work for your camera. Your tablet needed a whole different thing.
Yeah.
Total mess of cables, right?
Right.
And then, bam, USB-C comes along.
Right.
Suddenly, everything's so much easier. One cable for, like, everything. Well, something kind of like that is happening right now in the AI world, and that's what we're going to dig into today.
Interesting.
We've got all these crazy, powerful AI models popping up, but connecting them to the tools and data they need still kind of feels like searching through that old junk drawer of cables.
You're absolutely right. We're seeing this explosion of AI capabilities. But the reality is integrating them with, say, even a simple database or some specialized software or, heck, even another AI model, it often means building these custom one-off connections.
Right.
It's a fragmented landscape, and that's what we're going to dive into today.
Exactly. We're talking about what many are calling the USB-C of AI, the Model Context Protocol, or MCP.
Yeah.
Now, we're not talking about physical cables here, but the idea is the same. A standardized way for these really smart AI systems to talk to all sorts of data sources and tools without needing a ton of custom engineering every single time.
Right. So at its core, MCP is trying to be that universal translator, like you said. It's aiming to set up a consistent way for AI models to get the information they need, to use the tools they need to be effective, regardless of the tool or where the data lives.
Right. And to get a grip on all of this and what it means for you, we've got a really good collection of articles. We have an intro piece from Towards Data Science. It uses some cool analogies to help you understand it. There's a deep dive into the architecture from the official Model Context Protocol website itself. Then there's another article from Towards AI that really hits on why we need this standardization in the first place. And then we even have a piece from the Microsoft Community Hub on how MCP is being used with Azure. So lots of angles here.
Yeah, exactly. We're seeing the challenges from, developers actually doing the work, the solution being proposed, and how big players are already starting to use it.
Right. So our mission for this deep dive is to understand MCP. What is it? How does it work? And why is this a big deal for AI? Let's start with the basics. What is this integration fragmentation problem that MCP is supposed to fix? What's the pain point, so to speak?
Well, just think about how many AI models are out there right now. And that number is just growing all the time. You've got the big ones, OpenAI's GPT series, Anthropic's Claude, Meta's Llama, and then you have all these more specialized models coming out all the time. Each of these models has its own strengths and quirks. And these models don't just work in a vacuum, right? They need to be able to access and process information to be useful to you.
Right, like they need their fuel, they need data.
Exactly. And that data, it lives in so many different formats and so many different places. You've got data nicely organized in databases. Then you've got unstructured data, like scattered across different files. Real-time information coming through APIs, huge knowledge bases, even live data streams. And it gets even more complex because each of these sources might have its own rules about who can access it and its own security protocols. Just because an AI can understand language doesn't mean it automatically has permission to see everything.
And it's not just about getting the data, right? The AI also needs to be able to use tools to actually do something with it.
Exactly. Think about an AI assistant that needs to do a calculation or understand some code or connect to some specific service.
Right.
Each of these needs a custom approach, a custom connection for that specific interaction. And we can't forget about security and privacy. You're letting these AIs see potentially sensitive private data. You need strong ways to make sure the data is handled responsibly and kept safe.
So what you're painting here is this really complicated situation where you have all these different AIs that need to talk to all these different types of data and tools, each with its own rules and way of communicating. Sounds super inefficient.
It is. And this fragmentation, it has real downsides. One of the biggest is just the amount of development time it takes. Some reports say dev teams can spend up to 60% of their time just on this integration work. That's time they could be spending on the actual AI, the actual smarts.
60%. That's a huge amount of time just on making the connections.
It is. And then you run into vendor lock-in. If you build custom integrations for a specific AI provider or a specific data source, it's really hard and expensive to switch to something else later on. And because these are often custom built, they might not get the same level of security testing as a standard protocol.
Right.
That can create vulnerabilities. Plus, you have the ongoing maintenance as the models and the data sources change. It's a constant headache.
I remember you mentioned a diagram that shows this before MCP situation. Can you walk us through it?
Okay, so picture this. You have your main application in the center. To connect it to AI Model A, there's a dedicated custom path. To connect to AI Model B, another separate path. To get data from a specific database, yet another unique connection. So you end up with this web of individual point-to-point connections.
Right.
Each one needs its own development, its own maintenance.
Yeah.
And as you add more apps, more AI models, more data, it just gets out of control.
Sounds like a real nightmare. So how does MCP step in to fix this? You mentioned historical examples of standardization. Can you explain why those are relevant here?
Think about the early internet. Different computer networks use different protocols. It was a pain to get them to talk to each other.
Right.
Then TCP/IP came along, a standard set of rules that let any network talk to any other network. That's what really made the internet possible. Same with web standards. HTML, CSS, JavaScript, they all gave us a common language for building websites, making the web accessible to everyone. In the physical world, USB did the same for connecting devices. No more piles of cables. And for secure API access, we have things like OAuth.
So basically all these standards created a common language, a set of rules everyone could follow.
Exactly. And that made different systems work together. It made things so much simpler for everyone.
Right.
The AI world is facing a similar problem right now, and MCP is aiming to be that standard for how AI models talk to the world around them, making AI easier to use for everyone.
Okay, so let's get to the heart of it. What exactly is the Model Context Protocol?
In the simplest terms, MCP is an open protocol. It standardizes how applications give context to large language models. Think of it as setting up a common language and a set of rules for how AIs can ask for information, get information, and use tools in a consistent way.
You mentioned client-server architecture. Can you break down the key parts of the MCP system?
Sure. First, you have MCP hosts. These are the applications that want to use AI and access data using MCP. Like, think of apps like Claude Desktop, IDEs with AI features, or specialized AI tools. Inside these hosts, you have MCP clients. These clients maintain a direct connection with MCP servers.
Okay, so the client's part of the app that wants to use AI. What about the MCP servers? What do they do?
MCP servers are basically small programs. Each one exposes specific capabilities through the MCP protocol. One server might give you access to files on your computer, another to a database, another to an external API or some set of tools.
Okay.
These servers can talk to local data sources, the stuff on your own computer, like files and databases. And they can also talk to remote services, things that live on the internet and are accessible through APIs.
So the app with its client talks to these servers, and the servers handle actually talking to the data or the tool.
Exactly. It adds this layer of abstraction and control, which is really important.
Right. There's a diagram on the MCP website called Your Computer. Can you explain that?
Yeah, so in the diagram, you see the host app with its MCP client. It doesn't connect directly to your files or to some remote service.
Okay.
It talks to an MCP server, and that server's the one with the permissions and the knowledge to actually get that data. This is key for managing access and security.
So what are the big advantages of doing it this way? Why is this better than having the AI app connect to everything directly?
Well, there are a few big wins here. First, you have data locality. Because the MCP server acts as this middleman between the AI and your data, the data can stay on your own systems. It doesn't have to be sent to the AI provider. This is huge for security and compliance. Second, it offers flexible integration. You want to add a new data source, you can usually just set up a new MCP server for it. No need to change the AI or the app itself. And finally, it provides model portability. If different AIs all use MCP, you can potentially switch between them without rewriting all your data connections.
So that protects your investment and keeps you from being locked into one AI provider.
Eggs.
But how do these clients and servers actually talk to each other? What are the rules of the conversation?
That's where the protocol specifications come in. MCP defines a message format, which is based on JSON. This gives us a structured way for the client to make requests and the server to send back responses. For example, let's say the client wants to read a file. It would send a JSON message saying, "Hey, I want to read a file." It would specify the file path, and the server would send back a response, again in JSON, with the file content or an error message if something went wrong.
Like a well-defined API call.
Exactly. The specs also cover things like authentication, how the client and server prove they are, who they say they are, the standard resource types you can access, like files and databases, how errors are handled, and even a way to add extensions to the protocol for custom functionality.
So taking a step back, what's the big picture benefit of having all these standards in place?
It comes down to efficiency and security. Standardization means less development time. Developers can use existing MCP servers and clients instead of building custom stuff from scratch for every function. Okay.
It also means better security because you have best practices baked in and you can keep your sensitive data in controlled environments. And we've already talked about model flexibility and future proofing.
Right.
Plus, as more people use MCP, the ecosystem grows. You get more pre-built servers and tools you can use.
Okay, so we've got a good idea of what MCP is and why it matters. Let's dig deeper into how it actually works. Tell me more about this client-server model.
So as we said, the MCP clients usually live inside the host application, the AI tool you're using. They initiate all the requests to the MCP servers.
Right.
They handle managing the connection, authenticating themselves, formatting the messages, and then processing the responses from the server.
Okay, and the MCP server is on the other end of that conversation. Exactly. The servers receive the requests from the clients. They check if the client is allowed to make that request, figure out what data or service is being asked for, then they access that resource, which might mean talking to the actual resource provider, like a database or API. Then they format the information into a response and send it back to the client. And it's important to note these servers can run either locally on your computer or remotely on a network.
So there's a clear division of labor. The client focuses on the AI and the MCP standard, and the server takes care of securely accessing the data or tools.
Exactly. And this separation is a key part of the design.
Okay.
The clients don't need to know the ins and outs of talking to a specific database or API. They just need to speak MCP. The servers, they focus on security and don't need to know the details of the AI. And the resource providers, the actual data sources, they can keep doing their job without worrying about AI integration. This makes it much easier to maintain and scale.
Can you walk me through a typical scenario? Let's say the AI needs to get a specific piece of info.
Yeah.
How does that happen with MCP?
Sure. Imagine you're using Claude, and you ask a question that requires looking something up in a document on your company's network.
Okay.
Claude figures out it needs this external info and tells the MCP client about it. The client, which is part of Claude, formats this into a standard MCP request.
Right.
It sends this request to the MCP server. The server checks if the client is allowed to access this document and then talks to the actual resource provider, which in this case is your company's file system.
Okay.
The server gets the info from the document, formats it into an MCP response, and sends it back to the client. The client then gives this data back to Claude, which can then use it to answer your question.
Got it. So it's all happening behind the scenes to get the AI the info it needs. Security is a huge concern with AI and data.
Yeah.
How does MCP handle security?
Security is built into the core of MCP. We've already talked about data locality.
Right.
On top of that, MCP requires authentication. Only trusted clients can connect to servers. It also supports authorization, meaning the server admin can set fine-grained rules about what each client can access. All the communication is encrypted using strong encryption protocols.
Okay.
And the servers can keep detailed audit logs of every access attempt.
So MCP has these strong security features built in. What about data privacy? How does it handle that?
MCP is designed to minimize risks and protect privacy. One key thing is minimal data exposure. The AI only gets the specific data it asks for, not access to everything. The servers can also do data transformation before sending it to the client, like redacting sensitive info to protect privacy.
Okay.
The admins have detailed access controls on the servers, and importantly, access to the servers can be revoked at any time.
So they have a lot of ways to control and protect the data. For those listening who might want to use MCP, what tools are there to get started?
The MCP project has SDKs, or software development kits, to make it easier to implement. They have SDKs for Python, TypeScript, Java, and Kotlin. These are all popular languages, so there's something for everyone.
Having SDKs in these languages makes it much more accessible. What does implementing MCP actually look like?
Let's take a simple Python example. To set up an MCP client, you import the client class from the MCP library, create an instance of it, and connect it to the MCP server. For the server, you import the server class, create an instance, and register the resources you want to expose.
Okay.
For example, you might use a file resource to give controlled access to a folder on your computer. You'd specify things like the folder path and what file types are allowed. Then you start the server.
So that gets the basic communication set up. What about making an actual request to get data?
To make a request, you import the resource request class, create an instance, and specify what you want. You'd say, I want a file, and provide the path to the file. Then you use the client send request method to send the request to the server and get back a response.
And the response tells you if it worked or not and gives you the data.
Right. The response includes information about the outcome, the type of content, and the content itself. You then write code to handle that data based on its type.
Are there any tools to help with testing and debugging all of this?
Yes, there's a tool called the MCP inspector. It's specifically for testing and debugging MCP servers.
Okay.
You can connect it to a running server and manually send requests to see how it responds. You can examine all the details of the messages, which is really helpful for finding and fixing problems. The documentation has examples of how to use it.
Got it. And of course, logging is always important for any software.
Absolutely. The SDKs usually have built-in ways to set up logging for both the client and server, so you can track everything that's happening and diagnose any issues.
Okay, so we've covered the tech side of MCP. Now let's talk about real-world use cases. Where is this actually being used and what benefits is it delivering?
One area where MCP shines is enterprise data integration, where security and controlled access are really important. Think about knowledge management systems in big organizations. They have tons of information spread across different systems.
Right.
Using MCP, an AI assistant can securely access all those documents and their metadata through dedicated servers. Employees can use AI to find the information they need without compromising security. There's a diagram in one of the articles that shows how this works.
Makes sense. What other enterprise uses are there?
Another big one is customer data access. Companies in regulated industries like finance or healthcare, they need to be very careful about data privacy.
Right.
MCP lets AI assistants access customer databases through special servers that can redact or mask personal information before giving it to the AI. This lets them provide personalized service while still complying with regulations. And again, there's a diagram showing how this works.
So MCP acts like a guard, protecting sensitive data. What about using different AI models for different tasks? Can MCP help with that?
Definitely. MCP makes it easy to build multi-model AI applications. You could create what's called an intelligent router that uses the MCP client to send requests to different AI models. You might use one model for one task, another model for a different task. You get the flexibility to choose the best tool for the job, and you can see this in the intelligent router diagram.
What if one of those models goes down or gets too expensive?
MCP also helps with fallback mechanisms. You could have a primary AI model and a backup model, both connected through MCP.
Okay.
If the primary one fails or costs too much, you can automatically switch to the backup. There's a diagram that shows how this works.
That adds a lot of reliability.
Yeah.
You also mentioned secure data access patterns. Can you give some examples?
One interesting pattern is zero-knowledge processing. The raw data never leaves the secure MCP server. The server does the processing based on the AI's request and sends back only the final results, not the original data. The AI never sees the sensitive stuff. There's a diagram illustrating that. Another useful pattern is federated access, where an AI needs to access data from multiple servers, maybe in different departments or even different organizations.
Right.
The MCP client can handle this, getting the data from multiple servers securely. Again, there's a diagram showing this.
These are some really powerful ways to manage access. What about integrating AI with external tools?
MCP also provides a standardized way to connect AIs with tools. For example, an AI that needs to do calculations could use an MCP server that connects to a calculator service. Or, for more complex stuff, it could use a server that gives it access to a code execution environment, a safe place to run code. And to get information from the outside world, a server could connect to external APIs, like weather or stock market APIs. The diagrams show these different tool integrations.
These examples really show how versatile MCP is. Are there any real-world examples of companies using this and getting real benefits?
Yes, the articles have some great case studies. One financial services company used MCP to build a customer support chatbot that could access sensitive account data.
Yeah.
They saw a 40% reduction in call volume while maintaining security and compliance. A healthcare research group used MCP to give their researchers AI-powered access to medical literature and data, speeding up their reviews by 60%.
Wow.
And a law firm used MCP for confidential analysis of legal documents, cutting their review time by 70%.
So real companies are seeing real results with this.
They are.
Looking ahead, what's in store for MCP? What new features can we expect?
MCP is actively being developed. Security is a top priority. They're working on things like end-to-end encryption and hardware attestation to make it even more secure. They're also expanding the types of data sources it can handle, adding support for things like time series databases and graph databases. They're improving performance to deal with growing data volumes. They're working on better cross-language support so clients and servers written in different languages can talk to each other. And they're adding better monitoring and debugging tools.
So they're constantly improving it. What about adoption? Are more companies starting to use MCP?
Yes, it's gaining momentum. Big software vendors are starting to build MCP support into their products. Cloud providers are looking into offering managed MCP services. Startups are building on MCP from the ground up. And highly regulated industries like finance and healthcare are really interested in its security features.
It's becoming more and more popular. You said before that there are other standards for AI integration. How does MCP compare to those?
There are other initiatives out there, but MCP's focus on secure data access, especially in complex enterprise environments, makes it stand out. Security and privacy are baked into its design, which is crucial for companies working with sensitive data.
So what kind of impact could MCP have on the future of AI if it continues to grow?
It could be huge. By making AI integration easier and more secure, it could democratize AI development. Smaller teams could build powerful AI apps without getting stuck on the integration challenges.
Right.
This could lead to more innovation across all kinds of industries. The strong security will build trust in AI, especially when it's handling sensitive data. Model portability will give companies more flexibility, and the growing ecosystem will provide more tools and expertise, making AI more accessible.
You even mentioned things like federated AI systems and AI operating systems. Sounds pretty futuristic.
It does, but standards like MCP are what make these kinds of things possible.
Okay.
MCP could lay the groundwork for interconnected and autonomous AI systems and enable secure collaboration between organizations using AI.
So it really seems like MCP is the USB-C of AI, like we said at the beginning. It's about making AI connect to the world in a standardized, secure, and simple way.
Exactly. It's a solution to the fragmentation problem, giving both developers and organizations a lot of benefits.
And it's interesting to think about how MCP could play a key role in the development of AI agents. It provides the infrastructure for them to access the tools and information they need to work in the real world.
That's right. AI agent frameworks need this kind of secure and standardized connectivity to be reliable and effective.
So we've had a really interesting look at the Model Context Protocol. It seems like a crucial development for the future of AI. To all of you listening out there, think about this. How could a standardized approach like MCP change the way you work, how your organization uses AI, or even how you think about the possibilities of AI? We encourage you to check out the resources we mentioned and learn more about MCP. It's a development worth watching closely.